Hey folks, welcome back. This is Joel, and in this video we'll talk about an interesting use case where BGP can be used to share labels, right? To distribute labels, and how this can be used to create like a end-to-end unified MPLS architecture, right? Now, the concept is actually very easy, but there's also a lot of moving parts. So I will try to spend the first few minutes explaining what's really going around, right? In the whole scenario, and then we'll probably do a lab. Okay, so we've got like a typical service provider network, right? What do you see here? You've got like, say, this is a core network. You've got like a, think of this as a, access, right? You also have another access network, right? So think of this as like maybe Bangalore, this is like Delhi, right? Two different regions, right? And we all know that the goal of the service provider network is generally to connect, right, the two sides of a customer, right? Maybe this is maybe this is like the Bangalore side, maybe this is like the Delhi side, right? And the whole point is to the service provider normally provides services where you can connect these two guys at the L2 or L3, right? Maybe L2 VPNs, L3 VPNs, right? Cool. So that's the goal, right? And this is the typical service provider network. Okay. Now, again, not just to kind of explain this part, right? So we've got like a couple of the routers on the left side, right? So access 1, aggregation 1, core 1, these are iOS XE routers, and I've also used like iOS XR on the right side, right? Just to kind of give a flavor of both the configurations. Okay, coming back. So we talked about access, core, and access. Okay, so this is like a typical service provider network. Now what is the technology which normally runs, right, in the background? The technology which normally runs is your MPLS, right? Now again, contrary to what many people think, MPLS is not really going to go away. It's one of the most widely deployed technology out there. Even with some of your latest tools, right, like segment routing, you still use MPLS as your data plane, right? So we are going to be using MPLS as the use case, or we are going to be, this particular architecture we are talking here is about MPLS, right? Irrespective of whatever you might be using, segment routing, type of control plane, or you might be using any your typical old stuff, whatever you are doing, right? LDP and things like that, doesn't really matter. We are mainly concentrated on all architectures where MPLS is used as a data plane. Okay, so what really happens, like I said, we are going to be using MPLS, which means you need MPLS on all these links which you see here, right? Let me get rid of that first. Okay, so you need MPLS on all those links. Okay, and when I say MPLS, I actually mean what is the most common way to, what is the protocol which is used for label distribution? It is your LDP, correct? Label distribution protocol. So for LDP, before actually enabling LDP, what we normally do is we go and enable IGPs, right? Because you need a routing protocol, right? We all know that LDP basically works on the shortest path, right? So you need a IGP setup over there. In our topology, let's assume we are using OSPF here. Let's assume we are using ISIS, and here also we are using OSPF, right? Now, why are we using different routing protocols in different segments? The reason is because as the size of the service provider network grows, you don't want to have like one single OSPF area, right? Or you don't want one single ISIS level, right? And put one single ISIS area and put everything in that, because that will not really scale. So normally what people do is, right, what just happened? Yeah, so normally what people do is, what service providers do is, they segment their network and run different type of IGP domains, right, which is totally fine. Now, once I do that, next I would obviously go and enable LDP, right? On all the three domains, I would go and enable LDP, correct? So what does LDP do? LDP basically assigns labels, distributes the labels, correct? So in this domain, it is going to assign labels. Now, if I take an example of this router, the access 1 router, we'll have the label for 1.1.1. We'll also have label for 2.2.2, because that's part of the same, OSPF process. But this access 1 router will not have the label for 5.5. It will not have the label for 3.3, 4.4, or 6.6, correct? Because that is in a different IGP, right? And this access 1 doesn't really have the route for, any of those, right? So now that's a problem, correct? Because, one of the important thing in MPLS is you need to create a label switched path, right? What I mean by that, let me explain that. Let's assume that we the same example, right? So we want to create a service between these two guys. Let's assume that we want to create like a L2 VPN service, right? Maybe a point-to-point L2 VPN service, which means from this guy, which is access 1 to access 2, we will need to create like a targeted LDP session, right? And which also means that we need a end-to-end label switched path. Which what I mean by label switched path is if I get onto this access router and if I do a ping to 6.6.6, right? What we should be doing is we should be label switching it and not using IP to route it, right? We should be label switching it, which means in simple terms, access 1 should have the route for 6.6.6 and it should also have a label for 6.6.6, as simple as that. Now if all the three domains were, or I mean if we did not have three separate domains, if everything was in OSPF, it would have been very simple, right? You just enable LDP and obviously access 1 would have had connectivity to 6.6 and the LDP would have assigned and distributed label as well. But that is not the case. We have three separate routing protocols here, correct? So how do we solve this, right? Now that's where we'll be using BGP labeled Unicast, right? Now contrary to what many people might have studied till now, you might have studied that LDP is the only label distribution protocol. That is incorrect, right? In fact, in MPLS we can also use something called as, you might have already heard of this, something called as RSVP, right, protocol as well, right? For MPLS traffic engineering we use RSVP to assign labels. Similarly, BGP, which is probably one of the greatest protocol ever written, can also be used for assigning the labels, right? So we will be talking about how we can use BGP to kind of solve this problem. Okay, let me just clear my screen a bit. All right, coming back. So our goal is to, like I said, we basically need this 6.6 and its label, right? We need it on this access 1 router. That's our goal, right? So how about I create a IBGP between these two guys, right? IBGP. All right. So I create IBGP, and for a minute, let's assume that I'm using that labeled Unicast address family, right? And trust me on this, I will be doing the demo, so don't worry. For a minute, trust me that yes, this labeled Unicast address family works, and we will be able to share both the prefix as well as the label, right? A label will be assigned and will be advertised, right? Along with the BGP update, it will be advertised to the aggregation 2. Great. So we have the 6.6 and the label on aggregation 2 now, but we still need to come to the other side. So how about I then create a BGP here as well, IBGP here. Now why didn't I do it between aggregation and core 2? Because remember, one of the biggest advantage of using MPLS is BGP free core, right? Now if you don't really know this, I think I've done a detailed MPLS playlist on my channel. You will find it over there, or if you want to just quickly Google it, you can do it as well, right? But this is a very important concept. I will not dig too much on this because this will take quite some time to explain this, but for a minute, just trust me here that one of the biggest advantage of using MPLS is you can run your core network, which is the green part over here. You can basically run this without running BGP on individual routers. All you need is BGP between the edges, right? Like how I've done it here. Okay. And from here now, again, we have received the 6.6 on aggregation 1. How about I run one more IBGP and I come down here, right? So by doing this, do you think we have solved the problem? Kind of, right? There is still one more problem. Actually, there are two more problems and we'll solve that. But let me just clear the screen here. So, if you're, so this is basically common sense, right? What we have done is, we realized that we need a mechanism. We first of all realized that we have this, islands, right? We've got OSPF island here. We've got the ISIS. We have got OSPF, right? We realized that, how can we get 6.6 from here onto my access 1 router? Obviously one of the old school way of doing this would be through redistribution, right? You can redistribute from here, redistribute from here, obviously, but that's not a great way to do it, because then what's the point of even segmenting your network, right? If you are anyway going to redistribute, I would have just gone and used only one single area, right? And one OSPF process and one area and done with it, right? Why did I even go with the segments this way? Because I wanted my network to be scalable, right? I don't want too much of churn. I wanted to keep my routing domains separate, right? So obviously that is not a option at all. Redistribution is not an option, right? So the next option is to use a scalable protocol, right? Which can handle a lot of prefixes, right? Because as the service provider grows, there are going to be a lot of POPs, right? A lot of access networks, right? You might have Bangalore, you might have London, you might have Delhi, like you might have quite a big global network, right? So how do you basically make sure that you can exchange, right? How do you make sure that you can exchange all of these prefixes, right? In a very scalable way. The protocol obviously is BGP for its inherent, because it is designed for a more scalable use case, right? And second thing is, our use case is not just sharing the route, we also need to share the label, right? And we realize that this BGP labeled unicast is an address family which can be used for this purpose. Okay, now coming to this setup here, right? You do see some problem here, correct? What is the problem here? First of all, IBGP, how does IBGP work? IBGP needs, it has split horizon, right? We all know what is IBGP split horizon. So you basically need something like a route reflector over here, correct? So generally what people do is, the design which is used here is, we normally make this guy as a route reflector, right? I'm gonna put it as a route reflector over here. We make this guy as the route reflector client. Okay, with that what really happens is, the 6.6 comes onto the route reflector. We also make this guy as the route reflector client for this route reflector. Okay, so because of that, 6.6 gets reflected to my aggregation as well. Perfect. Now what we also do next is, let me use a different color. We make this guy as another route reflector, and we make this guy as the route reflector client for this route reflector, right? We also, in the reverse direction, we also make this guy as the route reflector client for this route reflector. You see what we are trying to do here? Now because of this, what happens is, the route which has already reached here, we have already discussed, it has reached here, but because this guy is the route reflector client, the route gets reflected and it arrives safely on the access 1 router. Make sense? Cool. So we have solved one problem. Other problem. What is the other problem? Remember, in IBGP, two things. Let's actually write it down. It's always nice to write these things down. One is, we solved the problem of full mesh, right? We solved it using route reflector. Second problem is next hop. There is a problem with next hop, correct? What happens is, because it is IGPP doesn't change the next hop by default. Because of that, your access to router, when it, when 6.6 is basically sent to aggregation 2, the next hop will be access to itself, right? And whenever these guys are reflecting, it will still reflect as access 2. That's not really going to fly, right? So if I come on to my access 1 router, if it shows in the route table that to go to 6.6, right, the next hop is access 2, then it's not really going to work, because I don't really have the route to access to. So I need to somehow make this guy as the next hop, right? So that is the reason what we also do is, we do next hop self, right? So we have to enable next hop self. So when this route basically gets reflected here, we basically do next hop self over here, and then when it gets reflected here, right? The first time we do the next hop self over here on the aggregation 2. So the next hop, right, gets changed from access 2 to this guy, right, to basically aggregation 2. And again, what we also do is, from aggregation 1, when it gets reflected to access 1, the next hop again gets changed to 2.2, which is the aggregation 1, right? So that is one important piece as well, right? The next hop part is very important. And we can do that. I mean, we have the we have the config commands to do it, but it's a very important piece. You need to do it, because otherwise, you might set up the whole thing, You might have set up the label unicast and everything, but it's not going to work, right? So, all right, just to summarize, let's come back. I mean, I think that is too much information, but let's try to digest it, right? So we started with a problem where you've got a service provider, 3 separate IGPs. You're trying to run MPLS. You're not able to do it successfully because you can't, your LDP is not really helping. Your LDP works within the domains. You can run LDP here, you can run LDP here, you can run LDP here. But what is really happening is when I get onto my access 1 router, I don't really have the route for 6.6. I don't have the label for 6.6 because it is in a completely different IGP, and LDP is not really helping here, right? For LDP to work, basically that particular prefix should be there in your routing table, right? So now we need to think of a solution. We came up with BGP because BGP is a more scalable protocol. So it solves 2 pieces. One is it can obviously exchange the routes. In this case, you're going to be exchanging routes, a lot of routes, right? Because you're going to have a lot of pops right across your global networks, a big service provider, right? So the second thing is it also solves the problem of sharing the labels. It can also advertise the labels just like LDP, right? But then when you're talking about BGP, we decided to go with IBGP. And when you're talking about IBGP, we will have to use the concept of route reflectors to get around the IBGP split horizon. Second thing is you also need to make sure that the next hop is correctly configured. Otherwise, your LDP is going to, your whole your route is going to be broken, right? You can't have a route through 6.6 with the next hop being 6.6, right? Or next hop being access to router. So we have to fix that by changing the next hop. Cool. So that's all done, right? So I think we will set this up, but before we probably start with the demo, let me also do one more thing. Let me just clear the screen one sec. Actually, let me start with the configuration, right? So we will do the packet walk at the last. I'll probably do this using a Wireshark, right? I think that'll be useful. All right, so what do I have is, right, the topology is pretty straightforward. What we'll do is we will forget about this C1 and C2 for now. That's going to be at the last. What we'll do is we'll first set up what we talked about, right? We'll set up OSPF in segment 1, ISIS in the segment 2, and the third one also we'll be setting up OSPF, right? Once we have OSPF, we will, obviously in addition to that, we'll also have LDP, right? So once all of that is done, we will do the BGP part, okay? So I don't want to spend a lot of time typing the configs. I'm gonna put the configurations and then I will show you the configurations in one shot. Okay, so let me go on to my screen. Let me pause the video at this point. Let me put in the configs and then I will quickly show you the configs which I've done, okay, so that we can save some time. All right, so we have the configurations in place, right? And I'll explain to you what I have done. All I have done at this point is I've put the IP addresses on the interfaces. I've created loopbacks and I've enabled routing, right? When I say routing, I've just done the, whatever I explained earlier, which is, let me just go back here. I've just done OSPF here. I've done ISIS here and then OSPF here, right? That's it. And I've put obviously IPs here on all the interfaces. And I've also created these loopbacks 1.1, 2.2 all the way to 6.6. That's what I've done, right? Let me show you the configs. And like I said, we are also using iOS XE for the first 3 routers, and the next 3 routers we are using iOS XR. So just to kind of give a flavor of both, right? So coming to access 1, right? So what do we have here? So this is a running config. Let me just show it to you over here. Yeah. So you've got a host name, and then as I scroll down, you can see one of the important thing is I'm using, by the way, CAT 8000 C8000V, right? The virtual router, and I think I'm using something like 17.7 or something. Doesn't really matter. You can use any release, right? But important thing is if you need to enable MPLS, you need to add this license command, right? So you need to enable the DNA advantage, right? You need to upgrade the license to this. You just need to add that command, reload the box, and then you'll be able to configure MPLS, right? Just FYI. Only this issue is only for the iOS XE devices. For iOS XR, it should work right out of the box, right? Anyway, so as you see the configs, I've put in 1.1 as a loopback, right? I've configured IPs on the interfaces. You can use any IPs. I'm using something like very straightforward, right? So I'm using 10.1, 2.1. I'll be using 2.2 on the peer device, right? OSPF is point to point, right? And so that's basically the interface on the access. There's only one interface connecting to the aggregation one, and you see have enabled OSPF, and after that, that's it, right? So I've enabled only OSPF. That's the only thing needed, correct? And by the way, I might have also enabled MPLS. As you see here under the gig interface one, you can see MPLS IP, right? Cool. Coming to aggregation one, again, iOS XE device. If I scroll to the top, right, I just have the I have the host name over here, and as I scroll down, I've got the license command, like I explained earlier. Where's the license command? I think over here. The license command is needed on all the iOS XE devices. I have the loopback 2.2, and because this particular router is part of ISIS, right? You can see I've enabled this 2.2 in both ISIS, and I might have also enabled it under OSPF as well, right? As you see under OSPF also I've enabled 2.2. Okay. And straightforward, right? Then I have the IPs, because aggregation 2, if you go back to the topology, right, you can see there are two interfaces. One is towards access 1, this is towards the core 1, right? And you can see I've enabled towards the access 1, I've enabled OSPF, towards the core 1, I've enabled ISIS, because like I said, right, I'm doing the segmentation. And you can see everywhere I'm using point to point. For ISIS also I'm using point to point. OSPF also I'm using point to point networks. Okay, just to kind of get rid of all the designated routers and DIS and all of that stuff, right? Always the best practice to do that. And then you can see the OSPF config. You can see ISIS config. The area is here. The net ID I'm using level 2, by the way, and I'm using metric style as white. Okay. So that's it. And then I might have enabled MPLS on both the interfaces, MPLS IP, MPLS IP. Okay. Similarly with core 1, I will not get too much here, will not spend too much time here, because it's again same thing, right? The configuration is very much same, only the IPs are going to change. You have the license command, you have the loopbacks, you have ISIS here. The two interfaces, both will be on ISIS here, because core 1, everything is inside the ISIS domain, right? You have the ISIS commands. Cool. Now coming to the iOS XR, the other core device is the iOS XR device. Okay, so you can see the configuration is slightly different here. You can see loopback is here. You can see the two physical interface IPs are here. The ISIS configuration, everything happens here, right? The ISIS router configuration is here. And you can also see the ISIS is also enabled on the loopback. It is also enabled on the gig 0 and gig 01, right? So that's how you do it here. And then MPLS LDP also needs to be enabled on this. So the configuration of iOS XR is slightly different from how you do the iOS XE. Okay. Similar thing applies for aggregation 2 as well, right? I'll just quickly flash the configs here. If you want to take a minute, you can pause it and look through it. You have the IPs, you have the routing, right? You also have OSPF here, because goes back to the topology which I explained earlier. And finally you have the access 2, which is another iOS XR router. By the way, I'm using I believe for the access 2 I'm using XRV 9K, right? If I want to show you the version, I believe I'm using XRV 9K 641, whereas for the rest of the two XR you can just use XRV, right? You don't really need XRV 9K. Anyway, so so that should be it, right? So this is all the all we have done is put the IPs on the interfaces, enabled IGP, enabled LDP. That's it. Okay. In fact, if I probably quickly look at the routes, right? So if I do show IP route on each of the boxes, you should be able to see the routes which are, for example, in access 1, you should see only OSPF, right? So you can see 1.1, you do see only 2.2. You don't see 3.3, 4.4, you don't see 6.6 basically, right? The main goal of our whole exercise was to somehow get 6.6 here. Right now you don't see it. On aggregation 1, you can see a bunch of routers, because this is like the border router. So it has some ISIS routes. It also has some OSPF route. But here also you don't see 6.6, right? 6.6 is going to be seen only where on the aggregation 2, right? You can see 6.6 is present here, right? The core 1 routing is here, right? The core 2 routing table is here. This is aggregation 2, and finally you have, let me show it here, show IP route. Did I make a mistake? One sec. Do show IP route. Let's just go out. Okay, one sec. Alright, so because this is XRB 9K, the show command is basically show route, right? And you can see the 5.5 showing up there. Okay. All right. So so that's basically everything which is there right now, right? So this is fine. This is still, we have not gone to the solution of our problem. We still have recreated the problem, which is on the access 1, I don't see 6.6, or from or on access 2, I don't see 1.1, right? Cool. So that's fine. Okay. So now let's actually, maybe one more thing, right? If you want to also be sure about this, we can also look at the MPLS table, correct? We can also have a quick look at the MPLS table here. So for example, on the access 1, what is the command? So it's going to be show MPLS forwarding table, right? There you go. So you see right now I just have the label for, the label is 16, right, for 2.2, right? The local label is 16, by the way, right? The outgoing label, I'll have to pop it because 2.2 is directly connected to access 1, right? Sorry, it's that, I mean, it's connected to aggregation 1, so you do implicit null, right? And you kind of pop the label. So that's why, you have to, you can also probably look at show IP sef 2.2.2, right? There you go. So so basically, yeah, that's the only label, or that's the only prefix and the label which I see on my access 1. I don't see 6.6, right? So I'll not be able to create a label switched path to access 2 right now in this scenario. So to solve that, what we will have to do is, the solution to our problem is obviously BGP, right? So we'll have to configure BGPs. How do you do that? Let me show you probably one example on the iOS XE side and one example on the XR side, right? So the configuration is pretty straightforward. So I can go with router BGP. AS number is 100. Neighbor, the neighbor is 2.2.2. Remote AS is going to be 100 as well, right? Because it is IBGP, right? Neighbor, let's also do update source, right? Because I want to use loopback 0 as my IP address for the BGP connections. Let's do now let's advertise the network, right? Which is the network? The loopback is what I want to advertise inside this BGP, right? So that's going to be the mask of /32, which is 255. Okay, I've advertised the required network. Now this is the most important part, right? For BGP labeled unicast, you need to go to the neighbor and say send label. There you go. That's it, right? But by doing that, you are now sending the label for what? For the for the route, for the network 1.1.1, right? You are sending the label to your peer. That's it. So that's the configuration, to be honest. Show run. Can I do BGP? Sorry, show run section BGP. Okay, that's the configuration, guys. As simple as that, right? So now, because on the aggregation 1, we have to make this guy as the route reflector, right? So let me actually do the configuration. I don't want to waste a lot of time typing, so let me do it. And all right, so here you go. This is the configuration for the BGP on the aggregation 1. And what you see here is the first commands are basically the neighbor commands towards the access 1. You can see the remote AS is 1.1, right? 1.1 is access 1 router. Remote AS is 100, update source is loopback 0, route reflector client, we're making 1.1, right? The access 1 as the route reflector client. Next hop self, right? So remember, we talked about this. We have to change the next hop, right? So we are saying next hop self for all. We are changing the next hop to aggregation 1, right? So all the routes which gets reflected from aggregation 1 to access 1, aggregation 1 becomes the next hop. And then we are also sending the label. Same thing on the other side as well, which is towards the 5.5. 5.5 is the aggregation 2, right? Same config, remote AS, update source, route reflector client, right? I explained to you earlier with the diagram, right? So we are making 5.5 as a route reflector client for aggregation 1, and next hop self all, right? And the send label. Cool. So that's the configuration needed on the iOS XE side. Now on the aggregation 2, we will basically do because it's iOS XR, right? So we'll have to do the other side. So let me do that. Give me a minute. All right. So that's the BGP configuration on the aggregation 2, right? So what do we have here? So we have router BGP, and remember we have to make the next hop self, right? So on the iOS XR, how you do is you add this particular command, which is IBGP policy out enforce modifications, and here you can see the way you do it here, right? For the labeled unicast is you first enable the address family IPv4 unicast, and then we say allocate label all, right? And then for each of the neighbor 2.2 and neighbor 6.6, right? The remote AS, the update source, address family IPv4, the address family labeled unicast is enabled, the route reflector client, right, which we spoke of earlier, and we are making next hop self, right? So same thing towards the 6.6. It's just a syntax different, right? Because it's iOS XR box, and same thing on the access 2 as well, right? So give me a second, let me do that. All right. So on the access 2, you have BGP 10, BGP 100. You just have only one neighbor, right? Which is the aggregation 2, but the configuration remains pretty much the same, right? Update source loopback 0. You are enabling the address family IPv4 labeled unicast. Okay, cool. So we have now put the solution in place. Okay, and the first thing you probably want to go and check here is, let's go and check on the access 1 what is really happening. Do you have show IP route? Remember earlier we did not have. Now let's go and check. There you go. So we see 6.6, right? It's coming through BGP. Perfect. So good, that's nice. Let's go and check your MPLS labels, right? So show MPLS forwarding. Actually, let's do one thing. Before we even do this, let me clear the screen a little bit here. Let's do a trace, right? Let's trace 6.6. Let's source it from loopback 0, right? Probe 1, right? So let's, because trace route will show you the labels, right? So we can then use the output from this trace route, and then we can retrace what is really happening, right? We can do like a packet by packet trace of what is happening. So we can look at the labels, each of the labels, and see where those labels are coming from, how is it getting switched, right? As you see right now, what is happening is you can see each of the hop is getting shown, right? So this is 2.2 is your aggregation 1, this is your core 1, this is your core 2, and at each of the place you can see what is the labels which are coming in. So you have label 22, right, which is getting imposed for the packet destined to 6.6, and when it goes to the next hop, you can see you have two new labels which are getting imposed, to be honest, right? So looks like the label which is getting imposed is 19 and 24,005, and then the 19 is getting swapped to 24,003, but the inner label, so you see this is a case of MPLS label stack, right? You have more than one label, and we'll talk about why you have more than one label, right? But what is happening is 19 is getting swapped with 24,003, and finally 24,003 is getting popped out, and you have you've got the 24,005 which gets popped up at the last, and the packet goes to the desired router. Cool. So this is what you have. Now let's see what is the meaning of each of these labels, right? So on the access, if I do something like show, let's look at first, is this label 22 what you see here, is this a MPLS, is it come from LDP, right? Let's check that. Show MPLS forwarding table. As you see here, I don't see this 22, correct? Because 6.6 is not available here. So where is it coming from? Definitely it's coming from BGP, right? So how do you see that? Show BGP IPv4 unicast labels, right? There you go. So you can see 6.6 is the network, and the label, the out label is 22. So that's why when you did a trace route to 6.6, the label 22 got slapped or got pushed onto the packet, right? So great. So you have now the label 22. Okay, what's happening next? So the 22 label gets assigned, right? And the next hop is obviously 2.2, right? And for 2.2 anyway, the label is pop here, right? So you don't have to insert any label. So the only one label which gets inserted is 22, correct? So now coming to the next guy. So on aggregation 1, what is happening? So on aggregation 1, as you see, we have 19 and 24,005. Let's see what this is, right? So let's run the same command, show MPLS forwarding table, right? So this guy, like I said, is adding 19 and 24,005. So what is 19? The out label of 19, as you see here, it is trying to add 19 here, and then there is 24,005, right? So what you see here is when the packet comes on the aggregation, it comes with the label of 22, correct? Because it is coming with the label of 22, and the 22 is because of this guy, right? So it's coming with 22, but 22 is getting swapped with 24,005, right? This is fine, it's getting swapped, right? This is how it is supposed to work. So you have an incoming label, and that gets swapped with the outgoing label, right? So this label actually is the BGP label, right, for 6.6, right? And it is getting swapped. This is fine. But what is also happening here is, the thing is, if you look at 6.6, right, the problem with this one is, let me just show you. So if I do something like maybe let's do show show MPLS forwarding table, maybe what's the next hop for 6. Now let me just let's actually do this, show IP ceph 6.6.6. that should do it. Yeah, there you go. So for IP ceph 6.6, it clearly says that we have two labels to be put here, right? So you see 22 is getting swapped to 24,005, and then 21, that's a local label, but ideally you are not getting any label, but you are going to be inserting label 19. So 19 and 24,005 are going in. But why do you want this 19, right? So you see this 19 is actually nothing but this guy, right? The 5.5. So what is really happening here is the next hop for 6.6.6 is basically 5.5.5, correct? So that's why you have two labels here. So if you do a packet capture, we'll do a packet capture later, and I'll show you that when the trace route, or when you do a ping, at this point we are basically going to have two labels. One label is the BGP label, which is the 24,005, which is the label for 6.6. But who is advertising 6.6, right? It is coming from aggregation 2, right, which is the 5.5. So that's why you have the other label, right? Make sense? Right? So we can also have a look at that here. If we do show we can look at the BGP labels here, show BGP IPv4 unicast labels, right? There you go. You can see 22 is getting swapped with 24,005, right? And the next hop is 5.5, and for 5.5 we have to use this table, and you have to now insert 19. So that's why you are finally going to have 19 and 24,005 getting slapped. Okay, coming to the core 1. So on core 1, what is happening? Again, same thing, show MPLS forwarding table. If you go back to our trace, you see we had 19 and 24,005. Next you have is the 24,005 remains as it is. We are not touching it because the core router doesn't really know about BGP, correct? We are running a BGP free core. So all the core router core 1 does is, it is just going to swap the topmost label, which is 24,003. And if you look here, the 24,003 is wait, sorry, my bad, not 24,000, no, not 24,003, 19. Basically it's going to swap 19. So if I see here, when the ink label is 19, it is going to slap 24,003, right? Because that is the label for reaching 5.5.5. Okay, so that is what you see here, right? So we can also probably look at show MPLS forwarding table labels 24, what is that, 003, right? So you can see that's it's label switched. Okay, cool. Anyway, so that's important, right? So we're done with core, right? And that's how you trace it, right? So that's what we did. So we looked at how it got swapped. So the inner label is still there, 24,005 is still there, right? So once you're done with core 1, what happens is it goes to so we did okay, let's continue. So we did core 1. Now let's probably go into the core 2. Sorry, I've signed out from here. Okay, let's clear the screen. So because this is an iOS XR device, I believe it is show MPLS forwarding. I think I have to use prefix here, which is 5.5.5/32, and you can see 24,003 gets popped, right? So that's what is happening. So if you see here, 24,003 is getting popped, right? So when it goes to the core 2, right, we are basically telling that if you get an incoming label with 24,003, the outgoing label is popped. Okay, and the next stop is 10.455, which is the aggregation 2, right? So when it comes down here, you can see it doesn't have the 24,003, correct? So on the aggregation 2, again, the only label which is left is 24,000. What is the label left is the 24,005. So let's look at what is this label, right? So let's get into this box. Okay, so if I do show MPLS forwarding labels 24,005, okay, there you go. So you can see 24,005 also gets popped here because it is relating to 6.6.6. Perfect. So that's how, as you see here, we have traced it, right? So what we found is, there is if I have to write it down here, what we really found is, let me just clear the screen a little bit. Okay, so what we really found is when the packet came from access 1 to this guy, there was one label, right? Let me just write the quantity of the labels, right? So or maybe let's just use this scenario what we have here, right? So we used 22. So we slapped the label 22 and we sent it here, right? While aggregation 1 sends it down here, what it did was the 22 was swapped for 19, right? So we are now having 19, which is the outer label, and then the inner label was 24,000. Was it 5? 24,005, yes. So the inner label was 24,005. So you had two labels at this point. Because this is BGP free core, right? BGP free core, right? So the MPLS here is just going to swap the outermost label. So 19 got swapped to 2000. So here, right, we still had 24,003 and 24,005. This is how it was, right? So that's what came on. 19 got swapped to this one, core 1. Core 2 received it. When core 2 sent it to aggregation 2, what it did was it popped 24,003, because 24,003 was actually nothing but the label for 5.5.5, because this was the next hop for 6.6, right? So it got popped and all you had was 24,005, right? That's what came to aggregation 2. And then on aggregation 2, we popped this one as well, so no labels, right? So when it came here, when the packet came here, 24,005 also got popped away because it was basically nothing but the label for 6.6. Okay, so yeah, so that's pretty interesting, right? So we basically saw how LDP and BGP labeled unicast is like working together, right? So you still need LDP because all these labels, right, are basically coming from that, right? So this 19, the 24,003, right, because you still need labels to forward packets in your MPLS core, right? That is still coming from your LDP. But we also saw how your BGP labeled unicast is sending this 24,005, right? The 24,005 label which is associated with it's a BGP label, right? So it basically is needed so that you can traverse this packet, right? And it can reach the correct destination, and this is possible using BGP labeled unicast. Okay, now one last thing what we can do is, a second. All right, so one last thing what we can do is, let me just get rid of this. We talked about how the MPLS core currently has two labels, right? We saw the label stack, right? In fact, okay, I think we did not do a packet capture. Let me do a packet capture, one sec. All right, so I just did a packet capture by doing a ping between 1.1 and 6.6, and I did the packet capture here between core 1 and core 2, right? Just to show you this. And you can see the two MPLS labels, right? One is 24,003, which is the label to reach 5.5, and 24,005, which is the label to kind of reach 6.6, right? Which is the BGP label. So this is the BGP label, this is the MPLS label. Okay, cool. So that is fine. Now the last thing which I also want to do here is very interesting. So what we'll do is we'll go ahead and create a L2 VPN service, right, between the two customer routers, and then we will see one more extra label. So right now we have seen two labels, right? Because one label we saw two labels because one label was used to reach 5.5, right? So aggregation, this guy added that label, right? Because this guy had to reach here, right? And then because this guy has to reach 6.6, he had already added one other label, right? So the second label was so that we reach 6.6. So we had two labels in the core. So at this point we saw two labels, correct? But now what we'll do is we'll create a L2 VPN service, right? A point-to-point L2 VPN service, right? I will not get too much into it, but remember we have talked about this in the previous videos on the channel. We using Xconnect and pseudo wires, right? So we can create a point-to-point service, and the point-to-point L2 VPN uses pseudo wires, right? So it will basically use targeted LDP session to exchange one more label for that service. Basically what we'll do is we'll create this maybe something like 10.1. maybe 1, and this guy is 10.1.1.2, right? We basically will create a service so that all the traffic which comes here, right, gets switched, right? Gets switched on a targeted LDP session, right? So it gets switched and these two endpoints, right, or these two C routers will appear as if they are connected to one single switch. So it'll appear like this is a C1, this is C2, it will appear right, they both are connected to one switch of this sort, right? So that's the whole L2 VPN service. But to do this, in the background, MPLS will assign a label, right, for this all the traffic coming from here. It will put a label, right, so that when the traffic is exiting on this part, right, it will know right to which particular interface I need to drop that particular traffic, right? So this is all done again using labels. So we already know that for the traffic to move between access 1 and access 2 we need two labels, but now since we need the traffic to move between C1 and C2, we are creating a L2 VPN. You'll need one more label, right, for the service label. So you'll see the three labels now in the packet capture. That's the whole goal, right? So let me configure that. I will configure that, and I will let me just go on here, right? All right, so let's actually quickly configure this. It's not a very lengthy configs, right? So I already have the two CE routers, nothing fancy. I just have show IP route, right? So I have put in a 10.1 IP here on CE1, and I have put on the CE2 I have already put the other IP, which is 10.1.1.2. okay, so all I need to do now is I need to create the L2 VPN service, right? So I will need to do this on the access 1, right? And how do we do this? Clear the screen, right? The interface is interface gig2. That's the interface connected towards the CE1, right? So I'm going to use gig2 no shot, no shot and let's create our service instance, right? You can create different there are different ways to create L2 VPNs. I'm going to be using like a typical what is this called as, I think this is called VPWS if I'm not wrong, right? Service instance 1, encapsulation is default, right? You can also use trunking and all of that. I'm not gonna do all that fancy stuff, just gonna do xconnect point to point. I'm just going to point it to 6.1, right? And encapsulation is MPLS. Okay, that's it. That's as simple as it gets. The other configuration on the access to is something which I will have to do. So I'm gonna do Cisco right? So on this guy, let me clear the screen again. Configure. So I will have to do on this, which is the interface. The interface is this interface 0001. Okay, and 1. Okay, that's the interface. Let's do L2 transport, no shut, and we will have to do L2 VPN, xconnect, right? Xconnect, we'll have to put a group. I think maybe XC should be fine. Then I will say this is a point-to-point circuit, right? Can give some random name. I'm gonna say customer 1, and the interface, which is the interface 0, 0, 3 zeros and one more 1. And what is the neighbor? The neighbor is access 1. So I'm gonna do 1.1. Let's put a sudo wire ID 1. Okay, that's it. Commit. So that should be fine. Do I know a show command to check this? I think show L2 VPN xconnect, enter. There you go. So right now the state is it down? Maybe it'll take some time. Okay, let's wait for a few seconds. Meanwhile, let's check from here what's up. Okay, so here it says sudo wire is up. Let's now check what is happening. Still state is DN. What does DN stand for? It's down. Okay, still DN. Okay, so let's wait for that. I'll wait for a few seconds, right, for it to come up. All right, so now it took a few seconds, but now I can see show L2 VPN xconnect, right? The state is up. I think the same thing should work here. Is it xconnect? Maybe not. Is it show? Okay, show xconnect all should give. Okay, there you go. So I think the xconnect is up, right? So the point-to-point stuff is up, which means we should be able to get onto my P1 router and see if I can do a ping to 10.1.1.2. And there you go, the ping works. Let's pull in the ping packet from here and see if we, give me a second, do I have the ping packet? Yes, I found the ping packet, so I think I should be able to pull it here. You can see here, maybe let's do one more ping, right? So I'm gonna keep this side by side, and I'm going to, it's not gonna be side by side, is it? Let's see if I can do that. So you can observe what's happening in the background. That's my packet capture, which is running. I'm just going to do a new ping again. And you can see a bunch of MPLS switched packets are showing up here, right? Now, if I click on any of these guys, right, you can see there are 3 labels, right? We already know about the 2 labels, right? The 24,003, 24,005, right? So we have already looked at those labels earlier, didn't we? Let me just go top. So jog our memory. I think here. Yeah, 24,003 and 24,005. We have already seen those 2 labels. 24,003 was to reach 5.5. This was to reach 6.6. But in addition to that, we have one more label this time, which is the 24,002, right? Which is getting inserted. And that label will be, I'm pretty sure, is associated with the xconnect, right? So let me just find the show command to check that. Give me a second. All right, that was pretty straightforward. The show command is actually show L2 VPN xconnect detail, right? So when I looked it up on the access to switch, access to router, you can see the label, right? For the service label is 24,002, right? So these labels are obviously exchanged using targeted LDP sessions between access 1 and access 2. So that's why access 1 is inserting this label, right, into the, into the packet, right? And that's why you see this is the most innermost label, right? The outer label is 24,003, right? The next second label is 24,005, and the last one to get popped, right, would be 24,002, right? So you see the labels get stacked, and each of these labels have different meanings. The first one is for purely MPLS, it's like a transport label, right? 24,005 is the BGP label, and the last one is the service label. Okay. All right, so that was everything which I wanted to talk, guys, in this video, right? I think that was too much information, but at the same time, you kind of got, I'm hoping you kind of got a good idea about a service provider network, right? Completely, right? So we kind of talked about a lot of things. We talked about IGP, we talked about LDP, we talked about BGP, right? Not just normal BGP, but BGP with this fancy label sharing business, right? And we also then figured out, okay, so we're going to use BGP because it is scalable, because it is it can share labels, but then also, right, we also figured out how to design that BGP, right? We used route reflectors. We also played around with the next hop self, right, to kind of make sure the next hops are reachable, right? Yeah, so that's basically everything which I wanted to cover here. And then finally, we obviously created a L2 VPN service and inserted one more label, right? So we were able to see, we did a packet capture here in the middle of the network, and we were able to see that at any point you'll be able to see three labels, right? You've got the transport label, you have the service label, transport label, the BGP label, and the service label, right? But yeah, this is really how most of the service providers use BGP, right, to kind of share labels and kind of connect all their various IGP domains, right, in a very systematic way. And this is going to be the basis not just for if you're running an MPLS network, but also like if you're doing SR MPLS and things like that, right? So this is the norm, right? This is the most recommended way to do it. All right, so hope that was useful. And thanks a lot for watching, guys, and have a good one. All right, bye.